Hi. Now, in this example, we've got this question here where we've given the cubic equation 2x cubed minus 3x squared plus 4x minus 6 equals 0. And we're told it has roots alpha, beta and gamma. And the question is, find the equation with roots alpha cubed, beta cubed and gamma cubed. Now we're also given this identity. The sum of the cubes of the roots, alpha cubed plus beta cubed plus gamma cubed, is identical then to this result here. And we're also given another identity, that is the sum of the product pairs of the cubes of the roots, okay? Alpha cubed beta cubed plus alpha cubed gamma cubed plus beta cubed gamma cubed is identical to this expression here. Now, I'm giving you these two identities without proof, but if you do want to check how these are proved, okay, do have a look at the links in the description to those particular proofs. Okay, you might want to have a go at this question. If so, just give you a few moments to pause the video. And when you come back, either fast forward to check your answer and working, or I'll take you slowly through that work solution. Okay, welcome back then if you had a go. So don't forget, you can either fast forward if you want to check your solution against mine, or I'll just take you slowly through it now. Now you should already be familiar with the form of a cubic equation in terms of its roots. If not, do go back and check the earlier videos on this, but basically it's x cubed minus the sum of the roots, okay, times x squared, plus the sum of the product pairs of roots times x minus the product of the roots, and that equation equals 0. So what we're going to need to put into these particular parts of this equation are the sum of the roots. Those roots now, being alpha cubed, beta cubed and gamma cubed, will be this result here. This is the sum of those new roots. We're also going to need to work out the sum of the product pairs of these new roots. That's this result here, okay? And as you can see, that these results are built up from knowing the sum of the roots, the product pairs of the original roots, and here the product of the original roots. So what we're going to need to do is turn to the theory of the roots of a cubic equation. And I showed you in the past that if we take a cubic equation of the form ax cubed plus bx squared plus cx plus d equal to 0, like in this one here, then the value of a would be 2, the value of b would be minus 3, c would be 4, and d would be minus 6. And I've showed you that if you look at the sum of the roots of a cubic equation, in this case alpha, beta and gamma, then I showed you that the sum of the roots, given by sigma alpha for short, that means alpha plus beta plus gamma, equals minus b over a. And when we substitute our values in, we're going to get 3 over 2. Remember, we've got minus 3 divided by 2. Okay, so that's going to give us the positive 3 over 2. Also, showed you that the sum of the product pairs of roots, given by sigma alpha beta for short, that was alpha beta plus alpha gamma plus beta gamma, okay, was equal to c over a. And if we substitute our values in, 4 over 2 for c and a respectively, you're going to get 2. And also, we've got the product of the roots, alpha, beta, gamma. That's given by minus d over a. So that's going to be negative 6 divided by 2, and that's going to give us 3. So we can use these results now, put these values into our identities and get the corresponding values. Okay, so we're going to start then with the form of the cubic equation. We know it's x cubed minus the sum of the new roots, so that's going to be alpha cubed plus beta cubed plus gamma cubed. Okay, and if we put that down, there it is in shorthand, sigma alpha cubed for alpha cubed plus beta cubed plus gamma cubed. And using this identity up here, substituting our values that we've got, starting with alpha plus beta plus gamma, that's 3 over 2, okay, and we cube that result. Then we've got minus 3 lots of the sum of those roots again, so that's minus 3 times 3 over 2. Then the sum of the product of the roots, that's given here as 2, so we can substitute that in. And then we've got plus 3 times the product of the roots. So that's 3 times the product of the roots, which we saw as 3. Work that out and you end up with 27 over 8. And that's going to be substituted into here later on. Next, we've got plus the sum of the product pairs of roots. So that's going to be this result here, okay? Alpha cubed, beta cubed, plus alpha cubed, gamma cubed, plus beta cubed, gamma cubed. So using this identity then, we've got this result here, okay? And we've got these values here, and that comes to 8. Lastly, we have the product of roots. And so the product of roots, alpha cubed, beta cubed, gamma cubed, well, that can be written as alpha, beta, gamma, all cubed. And we can pick up on the result down here. It's going to be 3 cubed, which comes to 27. So all I need to do now is substitute these values, respectively, into these terms in the equation. And if you do that, that new equation then with the roots alpha cubed, beta cubed, gamma cubed is going to be x cubed minus, okay, the sum of the roots, that's minus 27 over 8 times x squared, plus the product pairs, that sum of the product pairs of roots, that's going to be this value here, 8. Then we've got minus the product of roots, which we've seen as 27. So minus 27 there, and that equals 0. And you might want to multiply through by 8, okay, just to get rid of that fraction. And if you do, then you're going to get this result here. That cubic equation is 8x cubed minus 27x squared plus 64x minus 216, and it equals 0. Okay, so hope you're able to get that. If you had a go, got it, excellent, okay. If not, at least being able to see how to do it. Well, there we go. Hope you enjoyed that video, got something out of it. If so, do give us a like, and you might like to subscribe to my YouTube channel where you'll get updates of anything I put up. Okay, so thanks for watching. See you in another video. Bye for now.